So guys, in today's video, we are going to understand that why carboxyl group is said to be an acidic group. So in order to understand that, first of all, we have to make a point of the resonance structure of your carboxylic acid. That means what? For example, if I am going to write my general formula of a carboxylic acid group. So how will I going to write? RCOOH. Yes, in which you are having a carbonyl group, in which you are having a hydroxy group. But do remember what is happening over here. Due to the electronegativity difference between your carbon and this oxygen, this pi electrons which has been contributed by both which has been present in between both of your oxygen and the carbon will be more oriented towards your oxygen. Yes. So therefore what happens? Carbon will be having a partial positive charge. In order to balance that partial positive charge, this oxygen of your hydroxy group will not remain quiet. Okay, you have taken the electrons, I will give the electrons, it will say, and it will give. So therefore what we are observing in the resonance structure, the final formula will be given as RCO minus because it has taken one electron, a pair of electrons towards itself, and instead it has been given with a double bond character by the donation of the electrons of your oxygen of your hydroxy group. In turn, your oxygen gets a positive charge. Yes or no? So this is actually the resonance structure of your carboxylic group. So if you pay attention over here, what we are observing, of course, here oxygen has taken the electrons and oxygen has donated the electrons. But why did this oxygen take the electrons? Because it was more electronegative than the carbon. Of course, now here also the same funda lies. Here oxygen is having a positive charge. So what it will try to do, it will not remain quiet now. Instead, it will now undergo a heterolytic cleavage. What it will undergo? A heterolytic cleavage will take place between your oxygen and the hydrogen. Yes. And this bond will be overtaken by your oxygen, in turn giving you what? Yes, you will be having over here as a proton. Can you see? Here it explains the funda that carboxylic acid group is giving you a proton. Yes or no? Carboxylic acid group is giving you a proton. Any substance which gives a proton, we know it is an acid. This is a simple case. But we have to understand a major aspect over here. What is that? Whatever the reaction we have written over here, whatever the resonance structures we have written over here, it is majorly followed on its own accord. That means we are not supplying any energy. We are not applying any pressure. We are not maintaining any drastic conditions. That means in the room temperature itself, I repeat, in the room temperature itself, carboxylic acid group is wishing to give that proton. That means what? Here we have to not to neglect this part. So basically this is called as your carboxylate anion. Carboxylate anion. Why I am putting a significance over here? Remember guys, many times I have said it. If a product, if a molecule or if a compound is changing itself to something else, that means what? It is undergoing a condition where it can remain stable. Yes or no? The same thing lies over here. When we are observing the carboxylic group, it is itself going to some other rearrangement so that it can give a proton without any external energy. That means what? The carboxylic acid group is trying to get converted to the carboxylate anion. Why is it so? Because when we will study this carboxylate anion, it is resonance stabilized. What it is? It is resonance stabilized. And we know that in chemistry, a molecule or a compound always will try to be stable. So compared to your carboxylic acid, your carboxylate anion is more stable. So therefore, carboxylic acid can only go to carboxylate anion when by donating a proton. So that is the reason carboxylic group is called as an acidic group. Through the donation of a proton, the carboxylic group is jumping to the most stablest form, which is itself is carboxylate anion. So that is the reason we say that your carboxylic acid group is an acidic group. Is that clear? I repeat once again. Please do remember, carboxylic acid group ಏನುಂಟಲ್ವಾ ಅದು ಯಾವತ್ತೇ ಆದ್ರೂ ಒಂದು ಸ್ಟೇಬಲ್ ಮಾಲಿಕ್ಯೂಲ್ ಕನ್ವರ್ಟ್ ಆಗಕ್ಕೆ ಅದು ಪ್ರಯತ್ನ ಪಡುತ್ತೆ. ಸೊ ಆ ಪ್ರಯತ್ನದಲ್ಲಿ ಅದು ಎಲ್ಲಿಗೆ ಹೋಗ್ತಾ ಉಂಟು? ಇಫ್ ಯು ವಾಂಟ್ ಟು ಬಿ ಸ್ಟೇಬಲ್, ಇಟ್ ಹ್ಯಾಸ್ ಟು ಫಾರ್ಮ್ ಅ ಕಾರ್ಬೋಆಕ್ಸಿಲೇಟ್ ಆನಯನ್. ಅದು ಸ್ಟೇಬಲ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಈ ಕಾರ್ಬೋಆಕ್ಸಿಲೇಟ್ ಆನಯನ್ ನ ಫಾರ್ಮ್ ಮಾಡ್ಕೋಬೇಕು. ವೈ? ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ರೆಸೊನೆನ್ಸ್ ಸ್ಟೆಬಿಲೈಸ್ಡ್ ಆಸ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಓವರ್ ಹಿಯರ್. ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಬರಬೇಕು ಅಥವಾ ಈ ಒಂದು ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗಬೇಕು ನಮ್ಮ ಕಾರ್ಬೋಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಇಟ್ ಹ್ಯಾಸ್ ಟು ಗಿವ್ ಅ ಪ್ರೋಟಾನ್, ಒಂದು H+ ನ ಕೊಡಬೇಕು. ಸೊ ಅದು H+ ನ ಕೊಡ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಇಟ್ ಈಸ್ ಅನ್ ಅಸಿಡಿಕ್ ಗ್ರೂಪ್. ಏಬಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಯಾವುದೇ ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ ಇಲ್ದೇನೆ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಇದಾಗ್ತಾ ಇರೋದು. ಸೊ ದಟ್ ಈಸ್ ದ ರೀಸನ್ ವಾಟ್ ಇಟ್ ಇಸ್ ಶೋಯಿಂಗ್ ಟು ಅಸ್. Compared to the carboxylic acid group, your carboxylate anion is more stabilized. So that is the reason carboxylic acid will try to go to a state where it can attain the carboxylate anion structure. So that can be only attained when it undergoes a heterolytic cleavage to give this proton. So once it gives a proton, what it will be acting as an acid. So that is the reason your carboxylic group is called as to be an acidic group. Is that clear? Very much important. Now one question arises within us. Okay, sir, but when we were talking about the resonance structures of your carboxylic acid, of course our carboxylic group is also in resonance. Yes or no? This is your carboxylic group. It is also in the resonance. And you're also saying your carboxylate anion is also resonance. Both are resonance. Then why we are saying that carboxylate anion is only resonance stabilized? So if this is your question, very good question. Remember, when we are observing the structure of your carboxylic acid resonance structure, we could just see that there are two equal and opposite charges. Okay? Minus and a plus. And when we are observing the carboxylate anion structure, what we are observing, it is only having a negative charge. Do remember, ಈ ತರ ಎರಡು ಚಾರ್ಜಸ್ ನಿಮ್ಮ ಹತ್ರ ಇದ್ದಾಗ ಇಟ್ ವಿಲ್ ನಾಟ್ ಕಾಂಟ್ರಿಬ್ಯೂಟ್ ಎಫೆಕ್ಟಿವ್ಲಿ ಟು ದಿ ಹೈಬ್ರಿಡ್ ಸ್ಟ್ರಕ್ಚರ್. ಐ ರಿಪೀಟ್, ಒಂದು ಹೈಬ್ರಿಡ್ ಸ್ಟ್ರಕ್ಚರ್ ನ ಬರೀಬೇಕು ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಹ್ಯಾವ್ ಟು ರೈಟ್ ಅನ್ ಹೈಬ್ರಿಡ್ ಸ್ಟ್ರಕ್ಚರ್, ಓವರ್ ಆಲ್ ಸ್ಟ್ರಕ್ಚರ್, ದ ಈಕ್ವಲೆಂಟ್ ಸ್ಟ್ರಕ್ಚರ್ ನ ಬರೀಬೇಕು ಅಂದ್ರೆ ಐ ವಿಲ್ ರೈಟ್ ಇಟ್ ಇನ್ ದಿಸ್ ವೇ: RCO, and here one O is there. Yes, okay, here one double bond O alwa. So like this I would be writing. And overall I would be having a negative charge. That means what? This minus is being contributed to that of your oxygen. But if I want to write the equivalent structure for this group, it will be quite a difficult task to write me resonance hybrid. So the artha enu, this negative charge is contributing wholly, complete agi adu resonance hybrid ge contribute ಮಾಡ್ತಾ ಉಂಟು. ಆದ್ರೆ ಇಲ್ಲಿ ಆ ಒಂದು ಟೆಂಡೆನ್ಸಿ ಇರೋದಿಲ್ಲ. So compared to the carboxylic resonance structures, your carboxylate resonance structures are more stabilized. So that is the reason we say that your carboxylic acid will try to go in a position to obtain or to attain this carboxylate anion structure. By donating a proton, it acts as an acid. So that is the reason carboxylic group is said to be an acidic group. Is that clear? Very much important. So now let us draw a conclusion for a better understanding. Okay. So how can I write? If I am going to write R, C, double bond O and OH is there. Of course, now this will be undergoing in a resonance to give you what? Carboxylate anion. And this is possible by the donation of a proton. Why I am writing this? So that it will be easy for you to understand. So now this is less stable and this will be more stable. So through this reaction itself, we can easily get the major explanation. What is that? Always a molecule or a compound will try to rearrange itself to attain to the most stable state. So in the given reaction, we are observing that the carboxylic acid group is a less stable. So it can attain the major stability when it gets converted to the carboxylate anion. And during such a rearrangement, if it has to form a carboxylate anion, means what it has to do? It has to release a proton. Since it is releasing a proton, we can easily say that carboxylic group is an acidic group. Is that clear? So I think this will be a major important reaction which can easily explain the acidic nature of our carboxylic group. Okay. Now coming to some important note over here. Of course, we are observing over here one important aspect which we have also seen in our alcohols and phenols chapter. Can you recall it? Of course, yes. So when we are comparing the acidic nature of phenol and a phenoxide ion, I repeat, when we are comparing the acidic nature of phenol and a phenoxide ion, what did we say? Which is more acidic? Your phenoxide ion was more acidic. Why is it so? Compared to the phenol and the phenoxide, your phenoxide ion was more stable. That means by the loss of a proton, when phenol was undergoing a phenoxide ion, it would become majorly stable. The same aspect we have seen here also. So when I am comparing now carboxylic acid and a phenol group, okay, if there is a question that you're having a carboxylic group and that of your phenol, and the question is which is more acidic? Which is more acidic? Of course, carboxylic group is getting converted to carboxylate anion to be acidic. Phenol is undergoing a change to phenoxide ion to be acidic. Of course, the funda we know. But now the question arises, when we are comparing them both, which will be more acidic? Remember, your carboxylic groups will be more acidic. Carboxylic group or the carboxylic acid will be more acidic. Why is it so, sir? Remember, whatever the resonance structures we are seeing of the carboxylate anion, it is completely been contributed to its resonance hybrid structure. But when we talk about the resonance structures of your phenoxide ion, if I am writing over here, okay, here is your O minus, okay, so now this would be given, this would be taken, okay, it's an additional information I'm giving to you. So double bond O you will be getting over here negative, here like this. Then over here now you will be having, this would be contributing over here, this would be taken. So here you will be having a negative. So double bond O. And afterwards here it would be given, here it would be taken. So like this, double bond O, here minus, here you will be having the bond. Finally now this would be given, this would be taken, the final you can write it as, so here you are having as a O minus and this one. So when we are observing the resonance structures of your phenoxide ion, remember only the structures, that is your second, third and fourth. I repeat, only the structures second, third and fourth will not contribute to the resonance structure, whereas the structure in which the oxygen atom is having a negative charge, I repeat, the oxygen atom having the negative charge will only contribute to the resonance hybrid. So that is the reason what will happen compared to the carboxylate anion and that of your phenoxide ion, your carboxylate anion will be much more resonance stabilized. So that is the reason your carboxylic group will be more acidic than phenol. Keep this one in your mind, okay? One important note. Carboxylic acid will be more acidic than your phenol. The only reason is because in your carboxylic group, when it gets converted to the carboxylate anion, overall this resonance structure will be contributing to its resonance hybrid. But when we talk about a phenoxide, that is your phenol phenoxide ion, only the two structures in which you are having the oxygen atom is having a negative charge will be contributing to the resonance hybrid. So that is the reason which indicates and which makes a path to us to understand that your carboxylate anions are much more resonance stabilized when compared to the phenoxide ion. So that is the reason your carboxylic acid will be more acidic than that of your phenol. So keep this one in your mind, one important note. Coming to another aspect, when compared to your alkanes, and that is the similar molecular mass alkanes and your carboxylic acids, remember your carboxylic acids will be having the higher boiling point. Okay, it's one important note you just see with respect to the physical properties of carboxylic acids. Compared to the alkanes and the carboxylic acids of the similar molecular masses, remember your carboxylic acids will be having the higher boiling point because they can form easily a hydrogen bonds. They are having a much more hydrogen bonds within them. So in order to break that bond, we require an enormous amount of energy. So therefore, comparatively to your hydrocarbons and that of your carboxylic acids, your carboxylic acids will be having the higher boiling point. Is that clear? So we came to know that why carboxylic group is an acidic group. First important aspect. When we are comparing the second important aspect, we came to know that when we are comparing the carboxylic group and a phenolic group, your carboxylic acid group is more acidic. The reason is because the carboxylate anion resonance structures contribute wholly to the resonance hybrid, whereas phenoxide doesn't. Is that clear? So next important part, we are going to understand what will be the effect of substituents. I repeat, what will be the effect of substituents on your carboxylic group. That means if an electron withdrawing group is present, whether the acidic nature increases, or if the electron donating group is present, whether the acidic group decreases. So that will be understood when we look after the concept effect of substituents. Effect of substituents. So the next part we are going to study is the effect of substituents on acidic strength. On acidic strength. Yes. So basically we are going to understand over here what happens to the acidic strength of the carboxylic acid if an electron withdrawing group is present and electron donating group is present. So before that, I want to ask you a question. What is that? Of course, from the resonance structures of your carboxylic acid, we came to know one important aspect. What was that? Carboxylic group is acting as an acid only because it is getting converted to the carboxylate anion, which is more stable. And in order to attain that carboxylate anion structure, it has to donate a proton. So therefore, it is acting as an acid. So which indicates what? If it has to be more acidic, I repeat, if the carboxylic group has to be more acidic, it has to be whatever the groups which are present that is acting as a substituent should stabilize your carboxylate anion. Or in simple terms, it has to eliminate this hydrogen at a faster rate. Alva, it has to kick out this hydrogen at a faster rate. If a substituent is kicking out this hydrogen at a faster rate, what does it indicate? Its acidic strength is more. Yes or no? The same aspect we have to think over here. Now consider if an electron withdrawing group is present. Okay. R, C, double bond O and a OH group was there. Yes. Let to this R1Cl group is present. Yes, an electron withdrawing group. So what it will try to do? Easily because of its electron withdrawing tendency, it will make the carboxylic group in such a way that it has to release the proton at a faster rate. It has to release the proton at a faster rate. So once the proton has been kicked off easily, what happens to the acidic strength? Of course, it increases. Alva. So therefore, guys, remember, the electron withdrawing groups increases the acidic strength. What it is? Increases the acidic strength. So this is an important note one has to remember. Is that clear? So as the electron withdrawing groups increases, what happens to the acidic strength? It also goes on increases. The major aspect is simple. What it is trying to do, it is making sure that the molecule is kicking out the proton at a faster rate. For example, if I just say over here Cl, CH2, C double bond O and a OH. So what it will try to do, since it is a chloride which is an electron, so E part na tan kade elkono try madutte. What will happen over here? Somewhat its valency decreases. So what it will try to do, this will come over here. So in order to balance that one, what it will do, now this will come over there. So in turn, this oxygen, whatever the bond is present, it will break off easily. Yes or no? So in order to breaking off this easily, when it is happening, whenever an electron withdrawing groups are present. So which indicates what? So whenever an electron withdrawing groups are present, it increases the acidic strength of your carboxylic group. So do remember, if they are asking you by giving you certain examples, which I am going to show in this video itself, but you remember, you have to make a list of certain electron withdrawing groups like your Cl, your NO2. So they are all electron withdrawing groups. So whenever such groups are present to your carboxylic acid, of course it increases the acidic strength of your carboxylic acidic group. In the meanwhile, remember, your electron donating group decreases the acidic strength of your carboxylic acid. Decreases the acidic strength of your carboxylic acid. So important aspect, because many times it has been appeared in your board exams also. In your competitive exams, they will be giving you certain structures which will be dealt now in this video itself. But the major important thing one has to know that electron withdrawing groups increases the acidic strength because of your negative inductive effect, whereas an electron donating group decreases the acidic strength because of your positive inductive effect. So now let us have some additional information over here. What are those? Of course, I came to know that in case if you are having an electron withdrawing groups, it increases an acidic strength. So now if I'll give you a question, what is that? So these are your Cl, CH2, COOH, okay, and CH3, COOH, and CH, Cl2, COOH, okay, and Cl3, COOH, okay. Acetic acid, monochloroacetic acid, dichloroacetic acid, trichloroacetic acid. I have given you certain examples. I am asking you, arrange the following in the increasing order of the acidic strength. Increasing order of the acidic strength. Of course, what we came to know, whenever electron withdrawing groups are present, it is increasing the acidic strength. But in the given example or in the given question, of course, all are the what? Electron withdrawing groups itself. So how will you utilize your brain now? Remember, as the number of, I repeat, as the number of the electron withdrawing groups increases, what happens? Acidic strength also increases. So that means what will be least will be your acetic acid. Alva, it will be least. Then will be your monochloroacetic acid. Monochloroacetic acid. Then will be your dichloroacetic acid. Dichloroacetic acid. And at the final stage, you will be having your trichloroacetic acid, which will be highly acidic. Why? Because it is having 3 electron withdrawing groups. So as the number of the electron withdrawing groups increases, what happens? Very good. Acidic strength also increases. Okay. Now the second additional information, let me give it to you. What is that? So if I am going to give you 2-chloropropanoic acid and a 3-chloropropanoic acid, that means CH3, CHCl, COOH. Yes, 1, 2, 3, 4. This is your 2-chloro. if I am going to give you 3 chloro, CH2, Cl, CH2, COOH. 2 chloropropanoic acid and 3 chloropropanoic acid. And I am asking you, which is highly acidic? Yes, of course, now both are here mono substituents and only one electron withdrawing groups are present. So how will you analyze over here now? So guys, remember, whenever an electron withdrawing groups are present in a position very nearer to the carboxylic group, I repeat, closer the electron withdrawing group to your carboxylic group, it increases the acidic strength. Why? Because this has to, what it has to do, it has to come over here, then it has to come. Like that, shifting of the bond should take place. Whereas here what we can see, directly it is in the coordination with your carboxylic group. So therefore what it says, closer the electron withdrawing group, repeat, closer the electron withdrawing group to your carboxylic acid, higher will be the acidic strength of those compounds. Is that clear? So therefore your 2-chloropropanoic acid will be highly acidic when compared to that of your 3-chloropropanoic acid. So make a note over here. Closer the electron withdrawing group, I repeat, closer the electron withdrawing group to your carboxylic group, stronger is the acid. Is that clear? Very much important. So next important additional information, let us move on. So if I am going to give you CH3COOH, if I am having BrCH2COOH, I am having ICH2COOH, I am having ClCH2COOH and FCH2COOH. So here of course we got to know that halogens are electron withdrawing groups, and in all the cases we are having the halogens itself, but they are all different halogens. So how can you analyze in this situation? Remember, higher the electronegativity of your halogens, I repeat, higher the electronegativity of your halogens, greater is the strength of the acid. Of course, we came to know, since it is not having electron withdrawing or group, so this will be the least acidic, that is your acetic acid. Then which is highly electronegative? Of course, we know fluorine is the highly electronegative. So, and the least one is which one? Your iodine. So you will write as here ICH2COOH. Then, sorry, this will be in this way, alva. This is the least. Then here's your iodine. Then comes which one? Your bromine, bromoacetic acid, CH2COOH. Then will be your chloroacetic acid. And at the final, we will be having our fluoroacetic acid. So what does it indicates? Higher the electronegativity. I repeat, higher the electronegativity of your halogens, greater is the acidic strength of your acids. Is that clear? So we came to know very major aspects. What are those? As the number of the electron withdrawing groups increases, acidic strength increases. First important thing. Secondly, we also came to know what is that? As your electron withdrawing groups are present in a position which is nearer to the carboxylic group, so it will be increasing the acidic strength. And the third major aspect, we came to know that as the electronegativity of your halogens increases, what happens? Your acidic strength also increases. Is that clear? So let me give you one order. Okay, order of different electron withdrawing groups. Okay, it's an increasing order I am giving you. First is your phenyl group, which is least. Then is your iodine. Then is your bromine. Then is your chlorine. Then is your fluorine. This one we were knowing. This is just pH. If you are having as a benzoic acid, it will be least acidic. Okay. So then you are having which one? Now comes the major aspects. Then is your Cl. CN is also an electron withdrawing group. Then is our NO2, nitro group. Remember, the highest acidic strength will be to the compound to which CF3 group is attached. That means what? This is an highest electron withdrawing tendency is having on this CF3 group. Okay. So now let us give me an example for you. For example, if I give you CCl3COOH you are having. Okay. And you are having CF3COOH. And you are having NO2CH2COOH. And you are having NCCOOH. So of course you have to arrange it in the decreasing order. Now I am saying you have to arrange it in the decreasing order of your acidic strength. So highest is for which one? CF3COOH. Alva is the order. We can see that it is having the higher acidic strength. Then comes for which one? CCl3COOH. Yes. So then will be our NO2COOH, and the least in this case will be your NCCOOH. So this order is also very important. Make a note of it. First is your phenyl. Then as usual we have talked about the electronegativity. They have to just remember about this one. First comes CN, then comes NO2, then comes your CF3. So one major aspect what we came to know, electron withdrawing groups increases the acidic strength of your carboxylic acids. Is that clear? Very much important. So now let us have certain examples of your electron donating groups. Of course, we came to know that your electron donating groups, if they are present, they are going to decrease the acidic strength. Yes or no? Yes, Salva. So now if I am giving you formic acid, HCOOH, acetic acid, CH3COOH, and that of your ethanoic acid, CH3CH2COOH. And I am asking you to arrange it in the decreasing order of your acidic strength. Do remember guys, as the electron donating groups increases, of course the acidic strength decreases. First aspect. Second aspect you should also remember, as the size of the alkyl group increases, acidic strength also decreases. So the highest acidic will be your formic acid because it is not having any electron donating groups. So next will be our methanoic acid because only one alkyl group is present and the size is also less. So CH3COOH, and the least acidic will be our ethanoic acid because comparatively to methanoic acid, this is your propanoic acid. So compared to your ethanoic acid, your propanoic acid alkyl size is greater. So as the alkyl size increases, what happens? Acidic strength also decreases. So make a note of it. First, electron donating groups decreases the acidic strength. Second, as the alkyl size increases, your acidic strength also decreases. And one major important note you remember guys over here. Okay, within the electron donating group. Remember, I will just write it for you. Remember, direct attachment of groups like our vinyl or phenyl, remember, decreases the acidic strength. What it says? It decreases the acidic strength. Of course, you have come to know why is it so, because these groups, when they are present, they are decreasing the resonance structure, or we can say stabilize in whatever this, they are decreasing the resonance stabilization of your carboxylate anion. For example, if I'll give you a CH2 double bond CH single bond C OH double bond O. Okay, so this is your vinyl group. Yes or no? This is your carboxylic group. So what it is trying to do, you just see the resonance structures of this vinyl. So here you will be getting in this way. Yes. So this is your resonance structures, CH2 plus CH double bond COH and then O minus. It will not remain quite over here. So once again, now this would be given and this would be taken. So this form is formed where we could observe that it is not making the present condition so that carboxylate structure will be retained. So once the carboxylate anion is not retaining, what happens? Stability of that ion decreases. So that is only in the case when your vinyl or phenyl groups are present. So this is also one major aspect you have to know. Why I am saying this, for example, if you have been given with a questions, HCOOH, you have been given with CH2 double bond CHCOOH, and you have been given with CH3COOH. Of course, these structures are also an electron donating groups itself, where it is an acting as a vinyl group. Okay, as I mentioned, one phenyl group got put on a C6H5COOH. Of course, you can just see that here the vinyl group is directly attached to the carboxylic group. Phenyl group is also directly attached to the carboxylic group. So whenever these groups are attached, of course, it also decreases the acidic strength. So first will be your formic acid. Remember, very much important. Then will be our benzoic acid. Then will be our vinylic acid, CH2 double bond CHCOOH, and at last the least will be your acetic acid. Is that clear? Very much important. Of course, they are decreasing the acidic strength, but when compared to the acetic acid, their acidic strength will be somewhat more itself. Is that clear? Very much important. You have to make it as a note over here. So if I am giving you another explanation or another example, let me call. So here you are having as a COOH, and here you are having as an OCH3 you are having, and you are having over here, let me have just a COOH, yes, and you are having COOH and an NO2. So can you please arrange this in the increasing order of your acidic strength? Of course we can, because your methoxy group is an electron donating group. So of course it should be have the least stable when compared to the group or compared to the compound which is neither having any electron donating, nor it is having any electron withdrawing. So the highest will be acidic strength will be for our nitrobenzoic acid, because your nitro group acts as an electron withdrawing group. Is that clear? So this is the part of today's video where we have come to know that why carboxylic group is an acidic group. First important aspect, because it is getting converted to a most stable state, that is your carboxylate anion, by donating a proton. Since it donates a proton, when it attains a structure of a carboxylate anion, it is said to be an acidic group. Then we came to know that when we have a comparison between your carboxylic acid and that of your phenol, we came to know that your carboxylic acid or a carboxylic group will be highly acidic when compared to that of your phenols. Is that clear? Then we came to know with respect to the substituents, and one important part we came to know that whenever an electron withdrawing groups are present, it increases the acidic strength of your carboxylic acid. And within that we came to know, as the number of your electron withdrawing groups increases, acidic strength increases. Then we came to know, as your electron withdrawing groups are present in a position which is nearer to the carboxylic group, acidic strength increases. Then we came to know with respect to the halogens, as the electronegativity of the halogens goes on increases, what you can see, your acidic strength increases. Yes, and we also gave you an order where we came to know that your CF3 trifluorocarbon will be having it will be acting as a highest electron withdrawing group tendency. Then we came to know with respect to the electron donating groups, that is whenever an electron donating groups are present, of course it is going to decrease the acidic strength. Yes, and there we came to know with the increase in the alkyl size, your acidic strength also decreases. Then with respect to the aspect, that is your phenyl and the vinyl, of course these two groups are also, when they are directly attached to the carboxylic group, they are going to decrease the acidic strength, but it will be less when compared to that of your acetic acid, where we have given you an example. Remember, vinyl and a phenyl group has to be directly attached to your carboxylic group. Then we also saw some examples where you have been given with a methoxybenzoic acid, benzoic acid and a nitrobenzoic acid. And of course in the methoxybenzoic acid, your methoxy group is an electron donating group, so its acidic strength will be less when compared to the benzoic acid, which is neither having any electron donating groups nor any electron withdrawing groups. But when you are comparing the nitrobenzoic acid, it will be having the highest acidic strength. Okay, so this completes of today's video. So in our next session or next video, we'll be seeing certain reactions which involves the cleavage of our COH bond. Okay.